Our second equation in identifying limiting and excess reagents is a combustion. It tells us to take C2H5OH and incompletely combust. That tells me to add oxygen, form carbon monoxide, and water. Thinking about balancing, I'll start with the carbons, then work to the H's, and end with the O's. For combustion pattern, C's, then H's, then O's. We've got 2 carbons, so I start with a 2 in front of the CO. There's a total of 6 H's on the left, so I'll put a 3 in front of the water to get 6 H's. Now let's count those oxygen. We've got 2 plus 3 gives us 5. Here's 1 in the original reactant. Placing a 2 in front of the oxygen will get us a total of 5. So 1, 2, 2, 3 balances that equation. Letter B asks, how many molecules of carbon dioxide, and that's a mistake. I need to change the dioxide to say monoxide to match what we made for the incomplete combustion. So let's just decide to scribble off the di and make that correct to target the monoxide. We're going to begin with 136.2 liters of C2H5OH and 411 grams of oxygen. We're going to target molecules of carbon monoxide, so I'll get my target ready with 3 parentheses. We'll divide, ratio, multiply the 3 steps to stoichiometry with the same target, molecules of CO. In our first series of parentheses, C2H5OH is given to us in a liter unit, so to convert into moles we'll need the molar volume of 22.4. So 1 mole of C2H5OH set over 22.4 liters of C2H5OH. Our stoichiometric ratio, I have 2 moles of our target carbon monoxide for every 1 mole of C2H5OH. To bring it out to molecules, I need Avogadro's number, 6.02 times 10 to the 23rd molecules of carbon monoxide in every 1 mole of carbon monoxide. We'll start with 136.2 liters divided by the molar volume, 22.4, times 2 times Avogadro. I get 7.32 times 10 to the 24th molecules of CO. In our second parenthesis set, we're given oxygen and work to the same target, carbon monoxide molecules. Since we're at a gram unit for the reactant oxygen, we use molar mass of 32 grams in every 1 mole of oxygen. We notice the stoichiometric ratio would place 2 moles of CO on the top for every 2 moles of oxygen on the bottom, a 2/2 ratio. We're still counting, so 6.02 times 10 to the 23rd molecules of carbon monoxide in every 1 mole of carbon monoxide. So here we'll take 411, we'll divide by 32, multiply by Avogadro, and this answer gives me 7.7 times 10 to the 24th molecules of CO. 7.73 if I carry another decimal. The smaller of my 2 answers, 7.3 times 10 to the 24th, so this is my maximum yield, I'll label that. Making the C2H5OH our limiting reagent, and the excess reagent would be the 411 grams of oxygen. The maximum yield is just the smaller of our 2 answers, so that's the one I circled. The limiting reagent gave me the smaller answer. I like to label what's limiting and what's excess to make part C go a little bit smoother. We want to know how much excess was left over, so I have to know which one's my limiting and which one is the excess. I always begin by writing the limiting reagent, 136.2 liters of C2H5OH. Start with the limiting, and our target becomes the excess reagent. I want to report that in the same unit that it was given to me at to make subtraction go easier. Since oxygen was given to me in a gram, I'm going to go all the way to grams, even though we'll have to convert our answer back to moles to match what it asked us to do. In our first conversion, 1 mole of C2H5OH set over the molar volume of 22.4 liters C2H5OH. Our want over given ratio. We want the excess reagent, which is oxygen, so its coefficient of 2 up on the top, from the limiting reagent, 1 mole of C2H5OH. To bring it to a gram, we'll use the molar mass of oxygen, 32 grams, in every 1 mole. We'll start with 136.2 liters, divide by 22.4, our molar volume, times 2 for that conversion of 2 over 1, times 32, the molar mass of oxygen. This is 389.14 grams of oxygen. Reminding that that was consumed, used up during the reaction. Going back to see what we started with, we had 411 grams as the original mass of oxygen. Along the way, we used up 389.14. We'll take the difference between those 21.86 grams of oxygen is an excess amount. But I noticed in this problem it asked me to report my answer in a mole unit. So I just have one last conversion to take the grams of excess oxygen and report it out in a mole unit by using its molar mass of 32. So once I did my subtraction, I'll just convert it back into a mole by dividing by its molar mass, 32. This is where I find 0.683 moles.